welcome to day 2 of Star Prep. We are working on measurement conversions today. So still going to be using some of the proportions that we used yesterday, but now we're going to be applying them to a more real life situation. So things that we use measurement conversion for in real life is like especially baking. If you're given a recipe in one unit and you only have like measuring cups in a different, we use stuff like this all the time. So we definitely need to be able to convert between customary and metric units, which will both be covered in your small group. So don't worry, we'll cover like a little bit of each. In today's Google Classroom, we're just going to cover 4 questions between customary and metric, all using STAR format. So you should have out your conversion chart, the one that looks like this, because this is our best friend, and we can find this in the I think it's like the 3rd or 4th page of our STAR question or STAR test. And the first thing we're going to do, we're going to write our name on it. The second whoever's giving you your STAR test tells you that you can open it, you're going to go ahead and rip this page out and just keep it right next to you, because there's no reason not to have this out. It is front and back. The back page will have all of your geometry formulas on it. The front page will look like this, and it will have all of your conversion units on it. So go ahead and keep this out for today, and let's get started. So I know that the numbers look weird. It starts with the number 11. Just bear with me. Mrs. Torres is mailing a package that weighs 12.5 pounds. The post office charges by the ounce to mail a package. So I want to know, how much does this package weigh in ounces? Because the post office doesn't care about pounds, it only cares about ounces. I'm going to set up a proportion, just like we did yesterday. I'm going to set it up with the unit that I want over the unit that I have. So here, I want ounces, I have pounds. And on our conversion chart here, I see that 1 pound equals 16 ounces. So on my proportion, I'm going to say, okay, I have 16 ounces, still keeping ounces in my numerator, over 1 pound. So ounces in the numerator, pounds in the denominator, and all I took that from was it comes straight from the conversion chart. So this comes from our best friend. We're going to multiply by the number from the problem. So here, our number from the problem was 12.5 pounds. So we're taking the number from our best friend and multiplying by the number from the problem. Because these are kind of in fraction form, I can say, okay, well, this is a whole number, so I'm going to put it over 1. I can multiply straight across the top and straight across the bottom. When I multiply 16 times 12 and 5/10, I end up with 200 over 1. The very last thing that we need to do is figure out, well, what unit is this 200 in? Because I see pounds in the denominator and pounds in the numerator, they're actually going to cancel each other out because we see it twice. Once in the denominator and once in the numerator, they cancel each other out. And the only thing left is ounces. So I know that this is actually 200 ounces, which gives us answer choice B. For this second one, Greta is 1.5 meters tall. Which of the following would be equivalent to 1.5 meters? So we were given 1.5 meters. I want millimeters. So I want over half, same proportion as last time. Now I want milliliters. So millimeters. I have meters. Looking back at my conversion chart, I'm looking for millimeters to meters, which there actually is here. Oh, wait, what am I talking about? Right here. 1 meter equals 1,000 millimeters. So here I have my 1 meter and 1,000 millimeters. I'm multiplying by the number from the problem, which was 1 1/2 meters. I can cross off meters because I see it twice. Crossing off meters because I see it twice. And I end up with 1,500 milliliters. meters. I know it's millimeters at the end because millimeters is the only unit left. Meters got completely crossed out, and millimeters is my only unit left. So we're going to circle B. For these last two, Mrs. Jimerson buys a large bottle of cranberry juice each week. The bottle she buys contains 2,000 milliliters of juice. How many liters of juice will she buy in 6 weeks? So this one has two steps. First, we need to convert these milliliters into liters. Second, I'm going to multiply by 6 because she tells us, well, she buys one of these bottles in 1 week. So how many would she buy in 6 weeks? So we have two steps here. For my first step, let's convert those milliliters. So I want milliliters, I have liters. Going to my conversion chart, I see 1,000 milliliters equals 1 liter. So I'm going to put 1,000 milliliters over 1 liter times my number from the problem. Oh my gosh. Guys, I just messed that all up. I'm so sorry. We have to write this as want over have. Like I've been saying for the last two problems, and then I went and messed it up. Want over have. I want liters, right? Like all of my answer choices are in liters. So I'm going to write 1 liter over 1,000 milliliters. 1 liter over 1,000 milliliters. And I'm multiplying by 2,000 milliliters. Here I have that imaginary 1, and I'm multiplying straight across the top and straight across the bottom, which gives me a final solution of 2,000 over 1,000. We're crossing off the unit that we see twice, and we're left with liters at the end. However, I can simplify this. I'm going to divide both of these by 1,000, and I'd end up with 2 over 1 liters. But this amount is only what she buys in 1 week. Just for 1 week. The problem asks me, how many liters will she buy in 6 weeks? So I'm going to take those 2 liters for 1 week and multiply by 6 weeks to get 12 liters total. So answer choice A. I am so sorry that I messed this part up, but it is a really, really, really common mistake, and it's why we have to write want over have every single time. Because if you notice, this was the only problem that I didn't write want over have, and then I tried to skip that step this time, and of course I messed it up. Our very last problem right here, a bottle of orange juice contains 128 ounces. So how many cups does that bottle contain? This one is going to be your graded question for today. So I need you to go ahead and complete that on Google Classroom. You're going to close this video. It will be on that same tab, so you're still looking at measurement conversion, and your one question will be this one, number 2. So sorry about this mistake. Good luck on your graded question, and I will see you in small group.